Warmly welcome to University of Borås and Borås. The weather was really nice yesterday, but it's quite nice today. The MuseIT project represents an initiative that is both commendable and valuable. And as Vice Chancellor, I am honored to see it being implemented at the University of Borås. I'm also honored by welcoming you all to this, I don't say last event, I say this event, and hopefully we will find a way to continue this. This event with the extraordinary, thrilling name, I believe, Beyond Boundaries, Multisensory Innovations for Inclusive Futures. That is something to work for. I extend my best wishes for the ongoing work and hope that all of you and all of them that are traveling here now will find the event highly rewarding. Once again, heartily welcome. Thank you.
So I would like, many of you have already met us and you know about the project, but I thought I can start with telling you a little bit about the project to know what you can expect in the coming 2 days. As Mats mentioned, our symposium is called Beyond Boundaries, Multisensory Innovations for Inclusive Futures. And this has been a EU-funded project that started in 2022, and it will conclude at the end of this year. And in this project, we have been 12 different partners, around 70 different members, working at 12 different organizations, situated in 9 different countries, both in the European Union, but also in the UK and the US. So on the map, you can see where we are. And maybe I should mention those of you who need if you need to see the text, you can see them on the screen over there, which is the direct transcription. So the different partners, we have been academic partners, 4 of us here, University of Borås, CERT in Greece, a huge research center there, Stanford University, and King's College London. Then we also have had 4 different technical partners, Catalink from Cyprus, Exus from Greece, Actronica until recently from France, and X-System from UK. We also have had other stakeholders that are close to our end users, and we have Share Music and Performing Arts from Sweden, and from the cultural institutions, Microculture Association, situated in both France and Italy, but with headquarters in Belgium, and Ministero de Cultura from Italy. And also we have Dance from Netherlands that work with archiving and networking services. So the project has had 2 main focus user groups, cultural institutions and people living with disabilities. And we have been addressing 3 different challenges. First one is to broaden accessibility to cultural assets and make them accessible for everyone, regardless of needs. And we have done this by creating multisensory representations of the cultural assets. And some of it has been done through transformations using AI and sophisticated machine learning and AI systems. We also have had a side to it that we call subjective layer. And there we are inviting artists or creative people to bring their own interpretations of different objects to add other dimensions to the same object that you can see maybe in a physical form or visual form, but we can add to it in different ways. You will see examples of all of these this afternoon. And then we bring all of this together in what we call in our virtual museum. So you will see that as well shown later on. Then we also do something else. We would like people to be able to co-create and engage with cultural activities from wherever and depending. For example, if you have functional disability and cannot travel and you want to work from distance, that should be possible. Some things are very possible online. For example, you can have a Zoom meeting and create something together. But music is very difficult because it has to be so tight. And this has been a challenge that some of our colleagues in the project have taken on, creating a platform for co-performance and co-creation from distance without latency. And you will see examples of this tomorrow. So these are some images that show that people can be working together from different locations using online connection and still being part of the same team and in the same group. Finally, the third challenge that we have been addressing is to create methodologies for preserving and safeguarding cultural assets with inclusion at the core center idea. And the thing is that a lot of databases may not be very accessible, so we have that in mind. But that's not all. We have been thinking that the content should be by all. Many of barriers that we have created stops some people for their work to be part of the mainstream databases or media, or it takes a lot of time to get there. So we want to make it possible for content that is created in an inclusive way. Integration of multi-layered content. So if you are having multiple different representations of the same object, we would like, when you are searching on it, to get access to all of these different layers and different modalities. And also some of the modalities, like for example, haptic information, it's not really, there aren't many standards for it yet. And how do you preserve haptic data? So we have been trying to solve that as well and find ways of even including haptic data in our repository. So this is, in a nutshell, what we have been doing. And I said that the aim of the project has been to broaden access to cultural assets and also enhance participation in cultural experiences. So we have done quite a lot of things to achieve these things. One thing that we have done is been through making user studies and trying to understand the real needs of people, both people with disabilities, but also cultural institutions. So what is it that doesn't work? We also have been developing a lot of technological prototypes and methodologies to enhance accessibility. For example, multisensory representation, the virtual museum that you will see, and what we call MuseIT, picture to notes, and a platform for the co-performance that you will see tomorrow. Besides that, we have been also looking at alternative expressions and subjective interpretations that we have invited people to interpret maybe a physical object through music or through other mediums. Then we have been trying to facilitate communication, and for that we have, for example, developed a system called Haptiverse, where we are learning from the haptic communication that people already know, or tactile communication that people already know and create some haptic versions of that. We also have tried to make accessibility and participation more accessible through enhancing both the legal and the technical frameworks. So the technical framework is our repository and the way that we store and make information available. But on the legal side, we also do policy studies and look at what can be improved and create some policy recommendations. And finally, we are bringing all of this together through our MuseIT MuseIT Web UI user interface. So you will be able to access this and see them. So we will be presenting all of this under these different topics, one after another, in the coming hour. And we are hopefully going to keep in time. And beside that, I would like to say that we have not been alone in this project. We have had support of many people. Besides the funding that we have received from the European Commission, we, of course, have had quite a lot of advisors in the project. If I name them all, it will need its own maybe 15, 30 minutes time. But we have all of the names on our website. Please have a look. They have been really generous with their time and support to help us with ideas and sounding board and moving us forward. Some of them are already here today, and we are very happy to have you with us. And beside the colleagues that have been in our advisory board, we also would like to thank both the Swedish Textile Museum, which is actually in this building, that have been collaborating with us in creating some of the things that you will see today, and the Röhsska Museum of Design in Gothenburg, and that's where we will be tomorrow. And again, together with them, we have been collaborating to make some things possible. And beside them, we also have the city of Borås, who kindly has invited us to the dinner this evening. So with that, I leave it to my colleagues, and we will go through the different things that we have done. And I actually like to ask, is my colleague Elena online? And Elena, would you like to proceed, and I can go through the slides for you?
Sure, Nasrin, I'm trying to get my camera on. Very good. Let us, yes, I hope I am visible now. Okay, I'm presenting the results of the work package 2, which has been dealing with user needs, continuous participatory design, and design validations. Our aims were to ensure engagement with user communities, first of all with the cultural heritage institutions and the users of their services, mainly people with disabilities. We wanted to explore and better understand their real experiences, needs, identify specific requirements. And for this, we have prepared for co-design methodology, established the modes of evaluation of the interaction with user communities, and also shared understanding with the project about the user needs among our partners. And especially we paid attention to social model of disability. We use the approaches of participatory methodology, co-design activities, user studies. And during this whole period, since the project started to run, we organized and participated in 60 engagement activities. And this included 4 symposiums, one of them you are attending now, 14 participatory workshops and studies, sharing, understanding sessions, even one jam session. We also co-organized one project, Tactile Stories, and one ACM summer school, and participated in 13 conferences and external events. And there is more to come, and there is more that we have done. Here you see our engagement activities, which have taken place in different places, organized by different partners, but they were all based on the participatory methodology, and they led to overall results that we have achieved. That is increased understanding of needs, behavior, and collaborative potential of people with disabilities in using and creating culture. We also understood better co-design and co-creation methodologies that we created and implemented by all MuseIT partners. And also, we had the increasing understanding of the application of multisensory approaches in cultural institutions. And we understood their needs, experience, and potential in collaboration and in implementation of our technologies. We also had 3 deliverables and publications in scholarly journals. That's about it. Thank you for listening. And we are happy to answer your questions if you are interested. You also can contact us via email, MuseIT.
Great, thank you very much, Elena. So we can now move to the next speaker, and I leave it to you, Albert.
Nice. Brilliant. Thanks so much, Nazreen. I'm Albert Meroño. I'm really happy to be here today, and I'll be speaking on behalf of my team at King's College London, who've been working intensely in this topic of multimodal representations of cultural assets by using responsible AI, right? So the big idea of all the work that we've done is to use AI to address this big strategic objective of the project, right? Co-design and develop multi-layered, multi-sensory representations of tangible and intangible cultural assets. And in this picture, you can see kind of the canonical museum experience, right? So we typically walk through an artistic and cultural space, we stumble upon some piece of art, and usually we have next to it this descriptive label telling us what it is or how we need to interpret it. And the takeoff of all the work that we've done in using AI for multimodal representations is, well, can we use AI to broaden access to this kind of experience, right? So can we come up with multisensory representations that adapt to the needs of the users? And that's exactly what we've done in this condensed list of 5 main contributions. All of them have gone to international computer science conferences and journals. I won't bore you with the details about those, but are basically these 5 items, right? So the first one is what we call multimodal representations with generative AI. We've done here is to use generative AI models to come up with alternative ways of representing cultural heritage. And those ways sort of adapt to the sensory capacities of users. The second one that we realized while delivering the first one is multimodal fact-checking. As you all know, these generative AI models can struggle with hallucinations. They can be used for not so nice things, such as generating fake news and things like that. And we want to dive deep into understanding what are the pros and cons of using generative AI for inclusion and for alternative representations, and that is exactly what we did there. A different aspect is how these technologies affect the construction of databases and the work of knowledge engineers, right? So how do people use AI to come up with these representations? And that led us to a different part of the study of AI in disability and inclusion, which is current annotation protocols for semantic change in disability. So in what different ways have our understanding of disability changed through time? Because that understanding really permeates and leaks into AI models. And last but not least, I'll be talking a little bit about something called Croissant, which is a way of annotating AI datasets responsibly, including for better access and inclusion. This is sort of the takeoff point that we had at the beginning of the project with generative AI. We knew that generative AI models can achieve performance, they can do things, they can come up with new images, they can generate interesting text, but we really don't know how culturally aware they are, right? And we don't really know the extent to which they can be respectful and faithful to knowledge and to all kinds of different user circumstances. So that's why we based all of our work here in benchmark. So benchmark is generally just a structured way of running many different experiments. Cube was our way of doing it. This is a benchmark that was proposed last year at NeurIPS to understand the extent to which generative AI is culturally aware, right? So the extent to which AI can respect different cultures from different countries, on cuisine, landmarks, works of art, using different ways of prompting and using different models. And we extended that benchmark with CubeMT. So CubeMT is a way of generating through AI these surrogate multimedia representations that adapt to different user needs. You can see a little bit of the convoluted pipeline down there. It's really not that complex. All that we do is we take the cultural descriptions of items. This could be, for example, the painting of the Mona Lisa at the Louvre. And then we extract those properties and come up with structured ways of prompting different generative AI models with the properties of those works of art. And we use Wikidata for that, right? So Wikidata is this collaborative database where people can essentially say anything about any topic. And we use those descriptions to query all these generative AI models. And the ones that we use for the benchmark are, a couple by Stability AI, Meta, and Microsoft. This can be, and actually should be, swapped by other models that we want to test for different ways, for different cultural awareness. And we generated 6 different alternative representations for all of these works of art, right? So images, text, speech, music, 3D representations, and Braille. And we did this for every item. So that means that every item in the regional Cube collections and in many other collections of MuseIT has all these different 6 alternative representations. And you can see a little snapshot of what they look like here. So you can see the text descriptions, the generated images, the generated 3D models, and these 3D models can be printed, right, in a 3D printer, and we brought these 3D models to different user workshops that we organized mainly in London with people with aphasia for them to touch, right, so to use a different sense to perceive all these different items. All of this collection is available in the MuseIT Dataverse. As I said before, one important issue with when we're working with generative AI, especially for inclusion, is the problem of fact-checking, right? So we really don't know if what we are asking to be generated is faithful or not. And multimodal content is perceived even as more credible compared to, for example, just text. So for this, we developed a multimodal fact-checking survey. So we have a 3-stages process in which we can use multimodal assets and check their veracity, right? And these led to a huge collection of existing datasets and methods for multimodal fact-checking, which was really interesting. But what we learned from this was that there are many challenges that remain in understanding trust and traceability of AI-generated assets, right? So challenges like claim extraction, evidence retrieval, multilinguality, generalization, and generating justifications for users. This is just an example of a few of the many databases that exist for this. A different issue that we were trying to address when working with AI for inclusion was how can we come up with data models that are accurate and complete and of high quality when engineers design these data models and these databases, right? And these are typical challenges in knowledge engineering, right? So acquiring knowledge is very difficult. Assessing the quality of that knowledge is very difficult. And as I said before, dealing with different multimodal text, images, sound, video sources is very difficult. So we ran a study with all these fantastic people at King's College. We had an ethnographic study and a combination of different interviews to understand how engineers perceive the use of large language models in coming up with ontologies for inclusion and ontologies to describe multisensory experiences and disability. And all the three claims below we believe are true, right? So that LLMs lead to efficient engineering, but they require new skills, right? So they need to be used responsibly, they need to be used appropriately, and they have, as we know, issues of trust, right? That have been addressed, let's say, in the last couple of years while we were working on the project, but nevertheless, they persist. They also lead to quality ontologies, but it's still difficult to deal with complex scenarios, and we need humans in the loop. We cannot leave these things to work autonomously. And multimodality is, as we saw before, complex because of mixing these modalities, and they also require new skills. And just very quickly, the last two contributions that we had were an annotation protocol to understand how discourse about disability has changed over the years. This is very important because if we don't have good disability annotated datasets, we cannot expect AI to make the right decisions, right? It's going to be biased, it's going to be potentially offensive. So we came up with a new way of annotating datasets through time, spanning more than a century, on collections that have mentions of different disability terms that change over time. And last but not least, we made a big contribution to a raising standard in AI datasets. It's called Croissant. It's a high-level metadata language to describe the contents of machine learning datasets. And we believe this is very, very, very important because if datasets are annotated appropriately, we can train more faithful, we can train more trustable, we can train more respectful AI models, especially towards inclusion and disability. That's all I want to say. Thank you.
Hello everyone, my name is Maria Kiru and I'm a research assistant at CERT. Together with my team, we have developed a virtual museum for the MuseIT project. And what is our virtual museum? It's actually a multimodal and multisensory research space, and it aligns with the scope of MuseIT to make cultural artifacts and heritage more immersive and inclusive through multimodal and multisensory representations and alternative expressions. So this museum, how we designed this museum, it actually consists of 4 main thematic units. You can see on the slide 4 representative artifacts for each thematic. The first one has to do with the Roman landscape and aspect of depicting through artistic means, for example, through city plans and maps. The second one is a tribute to Rome's history. The third thematic unit is attributed to religion. In this thematic unit, we have also several 3D artifacts like sculptures, and religion is a unifying factor and representative aspect of people's identity through the ages. And the last thematic unit is about narrative, about people, and the way they perceive their role in history. So Actually, all these artifacts in all 4 thematic units are aligned with multi-layered representations. In the central area of our museum, there is an extra and very special thematic unit where it combines several effects. For example, we have visual artifacts like paintings and sculpture. We have also, of course, the descriptions, so a text for each artifact. There is also a text-to-speech component where this description for every artifact can be heard, and every artifact is also combined with audio and music. And of course, last but not least, we have haptic effects that accompany these artifacts. In addition, we have integrated other technologies like affective computing technologies. So by using physiological sensors like electroencephalography for brain activity, galvanic skin response for skin conductance, and blood volume pulse for heart rate and heart rate variability measures, we are able to get insights into the emotional states of our visitors during their navigation in the museum. This helps us to create a subjective, let's say, evaluation of the experience of our users. So the museum is a way to make culture accessible and enjoyable for everyone, as it promotes inclusion and accessibility through all these immersive and interactive technologies. The museum has multi-layered representations like visual, text, audio, musical, and of course haptic that provides us with diverse modes of engagement for different users and different user needs. We have also haptic technologies that enables tactile feedback, and that's quite innovative. That is actually synchronized with sound effects, and this way we can extend accessibility and offer new ways to interact with cultural artifacts and exhibitions. And lastly but not least, we have integrated in affective computing technologies to have emotional side that will help us in a subjective way to refine these immersive cultural experiences and make exhibitions not only more engaging but also more emotionally inclusive. Thank you.
Okay, hello. So I'm Vasilis, work in Catalink, and we have created MuseIT. So MuseIT is an innovative application where a user engages with a cultural artifact and their emotions are detected through AI. And on top of that, we have a knowledge graph which adds cultural semantics, and all of this goes into a music generation tool which generates music based on these three actually components. So it's 4 components. It's a mood estimation model, the stress estimation model, the cultural heritage knowledge graph, which gets us insight about culture, and then all of this goes into the music generation tool. So the mood estimation model, actually we use a camera where we record the visitor's face, and then we analyze their expressions and estimate their emotional state. This is being done through an AI model, which was trained on a custom dataset. And then it's the stress estimation model, which basically we detect stress through a a chest strap sensor, which goes on the chest. And then this model uses your heart signals to analyze your stress, basically, again, using an AI model. In the MuseIT project, we have created a knowledge graph, which many metadata and information about many cultural heritage artifacts are being stored there. And then because the user is interacting with, let's say, a painting, then we take these insights from the knowledge graph in order to make the music that we are going to generate to be actually, again, influenced by all of these metadata from the knowledge graph. And then all of this goes into the music generation algorithm, which basically it's a rule-based system that uses music theory rules to map musical features and emotional effects. We represent the emotions in the valence arousal model, which is a way to represent emotions. Actually, the valence is the x-axis, and it represents how positive or negative a feeling is. And the arousal is the y-axis, which represents how intense the emotion is. And then basically we use music theory to map how each musical feature changes your emotions based on this axis. For example, a higher arousal may result into a faster tempo, or lower valence results in a minor scale. And to add cultural context, we use our knowledge graph, which has many meaningful insights, like, let's say, the art period of an artifact. And since each art period has its own musical styles and themes, musical instruments and styles are changed and shift according to the corresponding period of the artifact. And then MuseIT, many cultural institutes and museums can benefit from it, since it is multisensory and can include people with visual impairments and limited mobility. Also, it offers an alternative sensory path, which make museums more inclusive and compliant. And then, since it is interactive, it can attract younger audiences and any kind of visitor looking to explore culture. That's all from me. Thank you very much.
Hey kids. I'm here to talk on behalf of the University of Borås, in which case I've collaborated on this project with my colleague Shanda Darani, who could not attend today, on the Pictures to Note application. So first we're going to talk a small bit about the problem domain, which we have focused on, a small bit about the theory, sort of what we're focusing, sort of what we were aiming to solve, shall we say. A small bit about the software stack we have, and ultimately what use cases we see for this in the future. So for the problem domain, as my colleague from King's College has already indicated, multimodality is often AI generated. So that gives us, when there's a data gap in that sense, because certain information is not available, it gives us a problem with the quality that's being rendered, or with the output of that model, essentially. We believe that adds, or rather subtracts from the experience of cultural heritage. So when it comes to multimodality, there's also a few platforms that natively work with that. Again, VR can certainly assist there, but in certain cases, especially when, say, as I said, when people are, have to visually interface with certain art, again, there may be some gaps there as well. In terms of data accessibility, we have museum databases, we have cultural heritage, say WikiArts or Wikidata, which we can harvest, but there's no single source of data which contains all the sensations and data which we need. And lastly, whatever AI generates is ultimately a question of whether it is true cultural heritage in that sense. Ultimately, it's new data we generate. As a result, the question whether it is cultural heritage at that point becomes a subjective question. So we came up with the concept of the modality clearinghouse. So the idea of a clearinghouse, for those of you who probably were born before the 1980s, is like a central agency for the collection, classification, distribution of information. What that means in simple terms is it is a place where we exchange information for a different type of information. So for example, for what we're about to see, is what we've done is we've taken a picture. We have translated that based on RGB color to optic frequency. say, ultimately frequency, and then translate that to haptics and sound. Another thing might be, for example, is concept. What is actually on the painting? Are we looking at a seascape? Are we looking at a person? And that can be translated by concept expressed by voice, or again by something called haptic subject index, namely haptification of certain concepts through social haptic communication, which we'll hear more about in the Haptiverse part in that sense. So the key traits of the clearinghouse here is that it's extensible. We can add new sensations to it, or we can add new types of data to it. It's exchangeable. So in case that we find out that the sensations which are being produced or generated are not useful or experience is pleasant, we can swap out one part without influencing the others. And lastly, we can express both semantic and non-semantic features. We can talk about what's on the painting, and we can also talk about how it's been painted, like what brushstrokes, what colors, that sort of stuff. So for example, we have here the Halbindian mit Fruchten by Leo Putz, and on the left is the original. On the right is the process which our software has gone through, which has converted the colors to a predefined scheme, which allows us to express them in such a way that we can haptically and sonically encode them. So when somebody, we'll get to that in a moment, but in short, when somebody interacts with the right side of the painting, they will experience different sensations based on what color they hover. The way we came about this this sort of like orchestration is that we generated the pictures by using the orchestrator, then stored that information in Dataverse, and then exposed it via the Access frontend, and ultimately that's running behind our own application. So the result of that is a web accessible environment which allows you to observe and see certain pictures and use a mouse cursor to interact with them and experience cultural heritage in that way. There are different modes, which we'll see in the afternoon in terms of exploration. So the use cases we have there is validating the multimodal data which we have generated. So it's because it's web accessible and because it's stored in Dataverse where we extract the information, it's exposed via FAIR principles. So that means it's also remotely accessible by others rather than ourselves. So the sound appears in that sense like an intuitive bridge, meaning we found people are it's easy for people to associate sound with color in that sense. In terms of making it remotely accessible and web-based, so this opens up avenues of human validation. We've generated this data at this point, or rather we have generated and exposed this data, which means that it's a starting ground for other experimentation, for others to continue where we sort of left off. That, I believe, is my presentation for this segment.
Thanks very much. Good morning. Still morning, I think. This has been a huge pleasure to work with people in this room. A great honor. Really enjoyed it. From the very start, Nasreen, your inspiring herding of us together to make this thing work. And then every moment that followed has been pure joy. Thank you. I'm a citizen of Scotland. A country that gave Europe its biggest vote ever. When we voted to stay in the European Union, in every single constituency in Scotland, there was no exception. The bit next bit of the story is rather sad, but however, it makes being here and part of Europe in Horizon very meaningful for people coming from Scotland. It is our home. So thank you for welcoming us back in our home. Moving on. So, where did our project come from, our part of the project? A lifelong, age-long problem for people working with creativity and disability is it's difficult to get people together sometimes. Difficult to move around. Difficult to co-create in the same space sometimes. That's an age-old problem. Then came the pandemic to turn that into something even more urgent as a problem, even more acute. And we knew we had to act at that point. There were problems, though. The technologies, like for us musicians, that were available, Zoom, Teams, and so on, had latencies, big delays, which meant that we could not play together we could not co-create. And so that we were left with that problem, which remained after the pandemic, when none of the old problems had gone away. So one of our principal motivations was to create a communication system that enabled people to co-create remotely and in dignity and in their own homes and with good communication one with another. To do that, we were lucky enough to be able to make an association with Stanford University that had developed already JackTrip, which is a low latency system. It's not a zero latency system, but low latency system. And they were very happy, particularly Patricia Alessandrini, our colleague there, was hugely helpful in bringing all of this together. And we were able to develop something that helped us with very, very little latency to communicate and with nice sound. So low latency, a user-centered design process, more about that in a moment, and communication of emotional states. Why was that important? Because when you're sitting next to somebody co-creating, you feel a lot of stuff. Visual cues, all sorts of communication systems are occurring between people. And that, when you're several miles or 100 miles or 1,000 kilometers apart, disappears. So how do we replace that process? So we were looking at ways, how can we inform one another of how we feel? How can we communicate our states of mind and body to one another? So that was a really big challenge. And as part of that also was how could that information, which we obviously would take with sensors of various kinds and communicate in the end through haptics and through avatars, but were there further uses for that emotional communication? For example, could it help people who did not have movement to be able to operate a system, maybe could not vocalize? But have, very active and creative brains. And so the question was, could we hijack that also to help people express themselves? Could we take their thoughts and turn them to sound? And of course, Catalink and SEAT have both developed systems related to that, and we were able to bring all of that together in our platform, together with our work system with EEG. And then, of course, to make this accessible to lots and lots of people. Very interesting phenomenon. Very often innovation exists at the fringes of our society. And in a way, the world of disability is on the edge of our society. It's been pushed there, but that doesn't matter. It's a noble place. And very often the real innovation occurs there. The center, nothing much happening at the center in our civilization. But from the margins, wow. Do we have a lot of interesting stuff? So that's what we think our platform can have that thing. Moving on very quickly, as I mentioned, JackTrip was our main tool, developed by Chris Chafe in Stanford. And I'll leave my colleagues to expand on this, but we added to JackTrip a data channel, which enables us to communicate all this other stuff. The emotional stuff can go together with the users. And finally, for me, hand over to colleagues, we had 7 participatory workshops with, I've calculated about 35 subjects, people with different disabilities, with whom we were working intensively. This is not just a one-off. We had 2-day, 3-day sessions often with them. And this gave us our basis in continually developing on feedback from users. We were lucky in Share Music because we've always had that good fortune with our Elefantura and other groups of people that we work with. And then finally, 9 what we might call performances of understanding or dissemination sessions, which probably got to about 5,000 people. We didn't get feedback from everybody, but we got some. So there's been a considerable base here of communication taking place. Then again, it is the ethos of Share Music. Anyway, it's how we think. And so I'm glad to say we achieved it in this project. Hand over to John.
Thank you, Nigel. I'm John Turner. Right, so I'm going to talk about the integrations we've done with partners here. So the co-creation platform to try and augment the just audio channel that people have when they're playing music together has a variety of different capabilities for outputting in different modalities. Sorry. The first one of these that we've got integrated is the Catalink stress estimation and mood estimation models, which use the Polar H10 heart sensor to evaluate the level of stress, which we're mapping to arousal in the same arousal valence model that's mentioned earlier. And they also have one which uses the webcam, which reads your facial expression. Both of these run locally on a local device, so not being sent out to anywhere to preserve people's privacy, and it's also just better for more reactive, lower latency interactions. And then the other integration we have with partners is using Surth's effective computing framework, which uses EEG data and streams EEG data from a unicorn brain interface, and then uses another local model to evaluate both arousal and valence. It can also use the blood volume pulse or galvanic skin response. And yeah, do we have a... Okay. And then we, taking those arousal and valence scores, then turn those into a few different outputs. First one to talk about is the visual output. And we did a series of workshops and got people to draw representation, like what they thought. The first workshop, we got people to talk about, to draw different representations that they thought would express their emotions. And got these kind of, some of them were sort of humanoid, or some of the animals, some of them more abstract. And so this last one, the third image here is, sorry, the next slide here. The third image here is this these dots which someone drew as their expression, and that's one which we decided to take and build a sort of animated dot system using a series of dynamical systems and Boids as a driving thing. Blank slide there. So here's the dots. Don't know if it'll play as a. I think. Oh no. No, I'll just skip that. Then was that over to you? Yeah. So I'll hand over to Rory.
Yeah, sorry, there's quite a lot of us involved in this, so we're rotating. So finally, as we sort of discussed, I mean, you know, the goal here was really to explore, you know, how we could kind of enhance this online communication space, and so we've talked a little bit about how, you know, we're using technology from Surth and Catalink to predict emotional state. And once we've made those predictions, you know, what can we do with those predictions? Well, as John was saying, you know, we can communicate them visually. We can have those emotional predictions, you know, influence and manipulate an avatar, which, you know, we developed a prototype was an abstract one, but, you know, I think it's important to note, you know, as this is a proof of concept project, that I think, you know, the idea applies to different types of representations. So I think, you know, it could be something more concrete, more humanoid. You know, I think there's a lot of different types of representations that could potentially work. And the other, you know, the final kind of point that we were looking at was, well, you know, since this is a music platform, you know, something we could do for accessibility was, well, can we actually use this emotional data to directly generate music? And as Vasilis was saying, actually, you know, he and Kathleen, they provided one way of doing this, using arousal and valence data and the changes in arousal and valence to manipulate some files, MIDI files. But we have another way of doing that, which unfortunately looks like the videos aren't working, so I can't show you, but we do have the demo session. You can try it. And this was to take your brain waves and first of all to directly audify brain waves. So your brains are producing waves just like musical waves, are just much lower frequencies. We basically pitch them up into a musical frequency band, and then we use that with a program called Somax, which is sort of like a library of musical sounds. Somax is a program that you feed in like a MIDI corpus or a musical file, and it will kind of slice it up into all its kind of atomical musical phrases and constituents, and then it will do a kind of template matching. So when this program now is listening to your brain live, it will listen and it will decide if your brain waves are similar enough to a particular musical template to play. So the effect of this is, you're sitting with the EEG cap on, and depending on how we adjust the parameters, your brain will just start spontaneously playing a musical instrument. And in a co-creative context, this is important because, if you choose the corpus in a particular way, then, depending on your musical context, if you're playing a particular concert, particular musical style, if you choose the corpus, then, your brainwaves, instead of being kind of dissonant and at different frequencies, will actually trigger, musical samples that are appropriate for the musical context. And this is, we tried this. We had great success with this at Pilot 1 in Rome. We had a lot of, users of disabilities and people in wheelchairs coming, and they just put on the cap, and suddenly they were making music. And even just by themselves, I think it's a powerful experience just to sit there and to, listen to the music that's coming from your brain. And we found, what was to me the benchmark of success here was that people were sitting and they could relate to this thing that was coming, because, you could very easily fake something like this. You could just play sounds like, oh, look, it's coming from your brain. But we found people really, were listening to this and, could see their reflection in this somehow. So yeah, video is not going to work. So just to summarize, that's what we did. This was sort of the first, as far as my understanding, the first attempt to kind of make this kind of platform. We're successful in integrating a lot of different technologies for emotional recognition, and we use these emotional recognition predictions in various different ways. Visual representations and musical representations, and we integrated this into a prototype platform. And we hope this can be, an example for future directions for these types of online spaces. Thank you.
So it's back to me, and sorry, John and Rory, that the video didn't work. So hopefully we can look at them later, but you will see the whole system tomorrow. So now we talk about something that we have developed in the project called the Haptiverse system, and it's a system to enable haptic communication. And we have been a team of people at HBX Boros who have been working on it, and my colleagues are here, Thomas and Jonas, and Rachel, who's not here, but we also had help from another colleague called Wansi. So there are different ways of communication for people with deaf blindness, and this stems from a previous project that we had focused on people with deaf blindness and haptic communication in that context. So it's very common for people with deaf blindness to use tactile sign language to communicate, similar to sign language. That usually is a visual thing. If you cannot see it, then you actually have to touch hands to be able to communicate in the same way as ordinary sign language. So this is called tactile sign language. So you can see that you are using hands on top or under to be able to talk or listen. Then we have social haptic communication that our colleagues here have been working on for 30 years, and it's a system of signals, of touch messages, and different ways of communicating that they will tell us a little bit more about. And we thought since this is a known system for people with deaf blindness, we might as well not teach them a new language or create a new language. We just emulate what they already have been using. Then we have protactile communication, which is similar, initiated in the US. There is print on palm, there is Tadoma, there is Braille, and different modes of communication that you can use touch and feel the alphabet, and finger Braille, and yes, these are the different ways, some of the ways that we communicate. But we don't want to replace any of them. We just want to complement them with an additional mode of communication for various reasons. So the type of challenges that this type of system can help with is, for example, difficulty in receiving real-time environmental and situational information. Maybe our colleagues, we can demonstrate later that when you are in a room like this, you always need to, we can see how many rows there are, how many people there are, but if you cannot see and you cannot hear, there would be some other ways of informing you of this information by touching and sending messages on the body. So then you would need an interpreter sitting next to you to do that. If you don't have that interpreter, or if you don't have the close proximity, that becomes difficult. So this is something that there was a challenge we wanted to address. Barriers in remote or one-to-many communications, like, for example, if you are not next to the person, how do you communicate with them from distance? Or if you want to send the same message at the same time to multiple people, like here, if we had multiple people with deaf blindness, each person would need an interpreter to tell them what is being spoken. Dependence on professionals trained in specialized communication methods. So if you don't have, you haven't planned and you haven't booked the interpreter and spontaneously want to capture some information, how would you do that? Also, sometimes social isolation due to reliance on interpreters. So if you don't have that, you might miss on some social communication if you don't have your interpreters with you. So this can be a complement. And restricted independence. We have had a lot of different interviews with people with deaf blindness, and sometimes you actually want to do something on your own without having to have an interpreter being that middle person. Difficulty maintaining confidentiality, and that's something that came up also in some of the interviews. And when I was asking the person, how do you feel about this interaction? One of them said, well, I cannot tell you because I have an interpreter telling you, and maybe I want to discuss that, but I cannot. So there are things that you can do. So that was a sign where people were actually signing. I wanted to jump quickly over it. But those are the social barriers that we address, but there are some technical challenges as well. Like if you are working with haptic communication, you all need to learn how to do the coding. You need to know the technical things behind it. So it's a startup learning phase that you have to go through to be able to create some haptic patterns and things, which means that you have to reinvent the wheel every time. If we do that with this system, that removes that barrier. And it also provides a test bed for many things, like, for example, we really don't have very good literature or studies on exactly how distant haptic or actuators should be for the body to perceive them best. There are some studies, but we don't know the exact actual numbers, so we wanted to create a test bed that different people can experiment and find the ultimate solutions. If you want to communicate from distance, that was a challenge that we are addressing. If you want to communicate one-to-many, enabling a common library of haptic patterns that didn't exist when we started, so we want something that everyone can use. Enabling community-based language development. As we know, language is a cultural thing and it develops through the community. I cannot sit here and create it for the community. If we had a system that enabled people to help together and create their own language and expand it, that would be useful. Providing a rich set of haptic patterns, haptograms for broad use. So you sometimes do it in limited groups. How can we make it available to the whole community, the whole world? So we have ambitions that this could be useful for anyone, anywhere. Enabling construction of haptic sentences, of words you can create. Now we enable how to put them together and create sentences. Development of a set of signs for musical notes. So this is just an example that it doesn't have to be limited to the language, and you can create signs for other things as well. And also, there is the social haptic communication community expands and creates new signs for everything all of the time. Now that we keep pushing them and say, oh, do you have a word for this? And do you have a sign for that? We are actually pushing them a little bit to speed up the creation of more signs. And enabling use of different interfaces so that we are not bound to the West or something that we create, so we can actually have it on any interface that people like themselves, and much more. So the system is called Haptiverse, and it has multiple different parts. We have boards, electronics that make it possible, HaptiMax, HaptiDesigner, which I will show you a quick image and you can see later. We have the wearable, which we call HaptiMesh, and the technical background, HaptiMax and Haptic Bridge, that make it all possible. This would be, for example, an example of our template that you can draw with a mouse to create a haptic pattern. And the cards that our colleague has created, they have been started when we started with previous project, quite large. They are becoming smaller and smaller, better managed. And also you can have them tiny little bit that you can connect them in serial mode. So that is our previous card in the previous project, hundreds of wires to manage. Now we are connecting them in serial mode and they sort of become a lot more manageable, and you can put them in any wearable or whatever that you want. And we will see more of this later, and it makes it very tidy and solves a lot of technical problems that others have made. And then our wearables, we are working on creating something both usable and versatile, but also quite nice to wear as well. So it's working, and we will show you more in the afternoon. So now I believe that my colleague from Netherlands, Andrea, might be online. Are you there, Andrea?
I am, and can you hear me?
Yes, very good. And I can change the slides for you. Just please tell me next, and I will move on.
Next slide. So this presentation is about the repository or the documentation side. And you already have seen in the kaleidoscope of presentations before that not only the material is where the artifacts are very rich produced in this project, but also their characteristics are very rich, and the way to describe them also became richer. Multimodality obviously plays a key role in the whole project. So how can that be kind of captured in a rather down-to-earth, normal kind of documentation mode, which is oriented towards long-term preservation of digital representation of those artifacts? So we started from a promise in the research proposal to create a repository, and then if a community wants to go this road, you usually have you can either go for commercial solutions, you can build something in-house, yeah, or you can, and that next slide is the road we took, you can try to
to be part of an open science kind of inspired in the public domain existing community. And because we at DANS, at the Royal Netherlands Academy, had various experiences with the Dataverse project, we finally, in consultation with the other partners, recommended to use Dataverse projects, and that has led to a couple of installments or instantiation of these Dataverse. Now, next slide. If you create a place where you can store kind of representation of complex objects, either which exist only digitally or which need to be translated into something digitally, then you are dealing with the data itself, but you're also dealing with the level of metadata, with the way you wanted to describe that. And how you order this, what kind of system, what kind of perspective you include in this description, that's usually called a knowledge base. And in this project, various groups have worked on kind of extending these ways to think about inclusion and accessibility and the related artifacts and the related communities for which these kind of new ways of interactions are actually designed. So next slide, please. This is about a specific instantiation with the Share Music partner, and I believe that also people from Share Music are present in Boras, and they are able to tell a bit more in discussions how they actually use this. This is the usual bread and butter Dataverse interface, but it is now instantiated and hosted by one of the partners, which is also always the best thing if you start in a European project for long-term maintenance, if people are kind of taking that over in their daily routines. So next slide, please. So what we were able to do is, it sounds small, but it is in the archival world, it is just a bigger achievement, namely that you have nowadays ways that you can extend metadata blocks, which are usually very generic for good reasons. They should be machine readable, they should be interoperable between different kind of instantiations of repositories, and still you wanted to also serve the specificity of the collection. So for that specific instantiation, we added kind of features like modality, or how to interact with an asset, with a data set, or what kind of art form is this data set representing. Next slide, please. And it's not only the kind of the extension of the metadata or the ontologies, those which take care of these collections also for the long term are interested to have. It came also with a discussion what kind of web interfaces you wanted to design to actually, for the case of Share Music, at the end bring every kind of effort together this organization does, from material and information expressed in news letters up to scientific articles, which are backing up a lot of the interaction the organization does. Next slide, please. And I think that's already my conclusion, and I will not read that. And in the next slide, you can also find some references to scholarly articles. And I believe you will have more questions on that. Thank you very much.
Thank you, Andrea. I hope yeah, it would have been nice to have your image. Oh, we had you for a short time. So okay, now we go to the next speaker, Thomas again.
Hey kids, I'm back. So today we're gonna, today, a few minutes later, this part's about the way we've constructed some of the data which we are using actually. So this is something done as, this process is called workflow orchestration. And again, We're going to walk a small bit through the domain problems, the way we've solved them, the approaches we've used there, as well as the results and the downstream data products which we are using. So in terms of domain, so the objective here was to have data available for well, cultural heritage artifacts in an accessible manner. Now, as I've illustrated, as I've mentioned before, that data does not exist in a unified or single format or in a single source. So you would think just splice it all together and we get there, right? It's unfortunately not that easy. So you're dealing with data which is describing artifacts which are hundreds of years old sometimes. Sometimes the information is unclear, it's missing, it's misformatted, or it could just be unknown. The schematic change, it may be schematically different. Some of it may be XML, some of it may be JSON based. And then you get into a scaling problem in the sense that you want to transform this information, normalize it for hundreds of objects. So this is not a task for humans, this is a task for automation and a machine. So typically this is done by a process called ETL. So extract, transform, load. You harvest data, you transform it, and then you move it to where it needs to go. So previously we've put together something for a project for a Dutch university together with Dans and the University of Amsterdam, de VU, called the workflow orchestrator. So this follows an ETL pipeline essentially in which we harvest information, source data, we transform it and then load it into Dataverse where it can be used for downstream tasks. We've gone a small bit further this time. So we'd usually in this case the pipeline is called ETL. In this case the transformation step also contains quite sizable amounts of enrichment. So essentially from the base data which we have, which is typically metadata or file data describing artworks, we generate new assets or files as we need it to go. So the orchestrator was set up in such a way as to allow any kind of tool to be used for that. So it's very accessible in the sense that we have very niche considerations sometimes. And as a result, we don't know what technical tools we're going to use. We just aim to be as accessible as possible. In this case, we've used a couple of different AI models. We've used schematic transformers and a couple of ingestion tools, which we developed earlier. So what you're seeing on the slide here is basically just the way the interface looks. So these are just tasks which are running, one for each artifact, and the individual steps which are happening for each workflow. So we have the ability to customize, plug in things, plug things out, and check what the different versions of outputs are essentially. So these are sort of called like flows, and they contain subflows which do specific tasks like transformations of files or metadata. So what that results in is a richer metadata layer for all the downstream data products, of which I'll show a couple in a bit. For example, some of the keywords are used for the graph. Some of the semantic embeddings are useful for generating, again, graphical stuff. The data goes ultimately inside Dataverse. And as a result, we have a scalable process which we can use for cultural heritage data in the future as well. Ultimately, you know, it's not a one-off. This is a factory we've built, not a car. So some of the stuff which comes downstream from this, for example, is the graphical data here. So this, for example, is an Eisenhower matrix allowing us to map urgency versus importance, for example. Another one could be, for example, a semantic cloud, which allows us to isolate certain topical similarities. So by looking at this graphically, it's much easier to analyze. Similarly, we can do force graphs like this, since you know we may be interested in the emotional impact or the effective potential of certain artworks and how it works over certain artwork streams, and ultimately we end up with a filled dataverse with the files we need, for example, for pictures to notes, but also all the other data which is there. Thank you for your attention, and moving on to the MuseIT Web UI by...
Thanks everyone for being here. And actually apologies for me not being able to be there with you all in person. So I'm Roberto Mafugli. I am a Research and Innovation Manager at Exus AI Labs. And before starting this presentation, I'd like to thank all the people who contributed to the material presented in this presentation. Stefan Bura, Michael Malter, who are there, Eleftheria Karataraki from Exus, and Stelios Kontogiannis, Georgia Christodoulou, and Vasilis Papadopoulos from Catalink. As you know, by now, the MuseIT project aims for increased accessibility and social inclusion and democratization of the access to cultural heritage. So it offers technologies that are designed to enhance and expand the ability of individuals with disability to explore and interact with and enjoy cultural assets, while also contributing to the preservation and protection of cultural assets in an inclusive manner. Now, most of the technologies that have been developed during the project are kind of summarized and showcased in the MuseIT Web UI. The MuseIT Web UI is an accessible website which is compliant to WCAG 2.2 standard, and the Web UI has multilingual support and is fully compatible with the screen readers. Now, from the MuseIT web user interface in its present version, but more updates are still upcoming, we can presently access three tools. The first one allows to browse the MuseIT knowledge base. So when users click on the Browse MuseIT knowledge base button, they will be redirected to a second web page that offers a library of material centered on inclusion in the area of creative arts and disability, which has been specifically developed and enriched throughout the duration of the MuseIT project. The second tool is a virtual reality multisensory museum tour, which has been curated and rendered within the MuseIT project. So by clicking on the VR museum tour button, the users will be able to download the application, which then they can easily enjoy on their personal computer using a VR headset. And then the third one, which we're going to discuss a little bit more in this presentation, allows to explore a collection of cultural heritage artifacts. This collection has the specific objective of increasing the accessibility through a multisensory representation of each artifact. So by clicking on the Explore Artifacts button, the user will be accessing a library of hundreds of artifacts. If you can move on to the next slide, please. In the page dedicated to the artifacts collection, we have a search bar which allows to search artifacts by name, author, or description. And there's also a filtering tool which which allows to filter the artifacts in the collection based on the category they belong to. If you can move on to the next slide. If we go then more in detail on the page where each artifact is displayed, we can see title, the author, and then below a textual description of the artifact itself. Below the image of the artwork, we can see three buttons. The first one is colors, the second one is contours, and the third one is concept. These are tools that convey a sound or haptic version of the artifacts, which is designed to go beyond the visual version of the artifact itself. So using the colors tool, the artifact color contours are simplified and color regions are mapped to a specific node or a haptic pattern. So when the user hovers over the color regions, they will hear the corresponding notes or experience the corresponding haptic stimulation if they're wearing a haptic device. If they use the contours tool instead, the users will hear an acoustic feedback that is proportional to how close the mouse pointer is to the color contour in the picture. And thirdly, the concepts tool maps the position of the pointer to specific objects or concepts present in the artwork. So for the artwork in the slide here, this concept could be sea, sky, light, shadow, door. And as the user hovers over the painting, the names of such concepts are spelled and corresponding haptic patterns drawn from a purposely built haptic dictionary are played on the user's haptic device. If you can move on to the next slide. This slide gives an example of how the artwork that was shown before is rendered in its contourified version with color regions that are mapped to specific sounds and haptic patterns. Now, to complement the feature of the web UI, users are also offered recommendations of similar artifacts, and those are provided through the MuseIT knowledge graph, which has been developed by MuseIT partner Catalyst. And my colleague Stelios, which I believe is in the room, will illustrate how this feature work and follow up with the rest of the presentation.
Hello, Roberto. Thank you for the presentation. I'm Stelios Kondogiannis from Catalink, and I will present you the last two features of the web UI. They are based on the knowledge graph that we presented previously, which we tried to unify all the data that we have across the sources and give them machine-readable meaning, and also enrich with metadata for further use. So the first app we built on top of the knowledge graph was a recommendation system engine that, for example, the user, let's say that lands in Rooms by the Sea artwork, then the engine instantly retrieves data from the knowledge graph regarding the author, the date or whatever, and also gets the description of this artwork. In practice, it turns those knowledge graph embeddings and the description embeddings it turns them into embeddings and it fuses them. This leads to further search in the collection for related artifacts, like those three that you can see below, that enable the user to discover further related artifacts and continue the journey in the UI. This approach is it matters because we do not need to build a profile for the user. It is context-based since we retrieve data from the navigation of the user. So it works from day one and doesn't need to be trained. And yeah, I think it also helps the user to continue navigating the web UI, making the experience more engaging. The second app we built on top of the knowledge graph is the MuseIT app, for which you saw a presentation earlier. It is embedded in the web UI with the green button you can see in the top right. So here we tried to create sound out of the viewer's experience. The system listens to two things. First of all, it listens to the mood of the user through the camera from the laptop. And the second one is the context that it retrieves from the artifacts that the user is viewing. It blends them, and through some rules, it reflects the experience as a soundtrack that is created during this exploration. Both of them you can try them later in the day live, and yeah, I think that's all from me.
So yes, thank you very much everyone for sharing your part of the project. But of course, as you can imagine, there is a whole lot more behind the short presentation that each person provided. And we would like to thank you for having listened to what we have said. And if you have any questions, we are here to answer them. And at this point, I also like to introduce to you our colleague, Raymond Holt, who will act as the moderator for the rest of the event from today and tomorrow. And yes.